flights. But also there's
recovery.
a quick recovery, and then also we call zero down of the problems and issues, and so we can tackle the problems and solve the problems of the Long March 5. And also there is a comparison between the Chinese spacecraft space station and the International Space Station. International Space Station is much bigger. It's like a football court, but the segment is contributed by different countries. The Chinese space station is autonomously built, so it can be assembled on the ground before we disassemble them and send them to space to assemble again. So we have many advantages. And the Wentian and Mengtian are different testing facilities. That is also we have the state-of-the-art technology that can be available today in comparison with 20 or 30 years ago when they built this International Space Station. So there are many agilities and advantages of the Chinese station that can be available to the Chinese space sector.
What sort of key technologies do you think are really notable, worth mentioning?
Well, I think the combustion is one of the traditional ways, what we call a combustion chamber in space. So that is very conventional. But there's some novelties. For example, the engineer have just mentioned that there's a robotic transmitting airlock that can be transmitting the cargoes from inside the Tiangong to outside. With no human presence, so the astronauts do not have to perform a EVA to bring the payloads.
Which is safer and everything.
Exactly, and also there's more than 30, we'll call it deployment port on board the Mengtian, so that is exposed to outer space. For example, if you put a spacecraft in one of the port, it can supply power, communication, and data transmission to the payload before it was deployed to outer space and leave the station. So these are some of the novelties and new things that is we have designed into the in particular Mengtian segment in comparison with the traditional stations.
So we were hearing earlier the engineers giving us an introduction about the sort of functions that the Mengtian will be carrying out, and it is primarily for studying microgravity, fluid physics. So what are some of the experiments you think we might expect to see?
Well, let's say in comparison with Wentian, Wentian is more what we call a biotechnology experiments, like microbes and
growing seeds, for example, we saw
seeds and growth of plantations and vegetations, and also crystalline crystallizations. Where in comparison with that, Mengtian is more focused on material science. What we call it material science. You can do combustions, fluid dynamics, extreme cryo temperature study of metals. So these are focused more on the material science itself. So the character of different elements in comparison with Mengtian. So that makes it complete. And also we have an exposed segment.
Right. Yeah. This is very interesting.
Yes, the exposed segment is not available on Wentian. So the Mengtian has its own unique novelty. As I mentioned, there are more than 30 deployable ports available on these segments, so that can deploy different payloads on board the station to outer space. For example, if you move a satellite into the Tiangong, and the astronauts can work on the satellite itself. So the Mengtian has the availability of the robotic airlock that can transport the satellite to the what we call deployment port, and then deploy to outer space. So we can launch the satellite without using a rocket.
Well, we're looking at pictures there of the rocket, and that's ready for launch in about 17 minutes or so, 20 minutes or so. And then also we're hearing some signals from the ground control there at the launch site, and I think the second check has just been completed, and it's Mr. Xu, so about these exposed sections for these experiments, I mean, this would be really interesting. But does this necessarily involve the astronauts themselves having to go outside to do, or can it all be controlled from the inside the lab?
Well, I think the exposed segment is the whole idea of that is to have robotic maneuverability of the exposed segment. Of course, this exposed segment is not new. We have the Japanese Kibo segment on board the International Space Station that also has exposed experiments. But the deployment port and the automatic, what we call it, robotic transport airlock is something new for the station. So we have also, as you remember, there's a robotic arm on board the station. One big ones and a couple of smaller ones, and they're quite adaptive, and they can be used for maneuvering the cargoes and the satellites itself. So there are many ways that astronauts do not have to go out to do this. There are robotic availabilities to the deployment of the station and deployment of the spacecraft, and also the external maneuverability of the exposed segment.
Will this be adding a lot more to the astronauts' workload then once the Mengtian arrives? I mean, they'll have double the amount of experiments to do, or possibly more.
I must say that they will have a lot of things to do. I think for material science, it's not like a plantation that you can put the racks and the boxes in the port together and just see the results as they grow very slowly. But combustion can happen very quickly. Fluid dynamics you have to record very carefully. All the material studies has to be recorded. So this is why the astronaut sometimes needs particular trainings for scientific missions, and this is why also the International Space Station, as well as future stations, we call there are a number of commercial stations that is going to be launched in the coming years. They also focused on scientific-oriented missions, and the scientists on site is more important than the pure astronauts themselves, because you have to have a scientific background to understand some of the experiments and studies performed on the microgravity environment on the station.
But that's the direction that we'll be seeing with China's future astronauts, isn't it? At the moment, these astronauts are, they're trained in, say, pilots background, for example. But in the future, I think the future batches, we might expect to see more scientists going up there. Exactly.
The Chinese manned space program started with in 1992 with zero background. So this is, from scratch. We have to have designs and manufacturing of the spacecraft, as well as the support of the life support system on board the station is focused on, well, let's say, healthy candidates. I mean, physical fitness is very important for the beginning of the mission. But once you have mature technologies, for example, the station is stabilized. And it's operating very stable and normal, and also the launching is very frequent and safe. So you have a normal human that can tolerate these travels and sustainable stay in station to perform the scientific missions. So that is what we're seeing. We're looking forward in the coming future, where they're selecting the third batch of their astronauts, and also they have international collaborations with the European and ESA countries that they can choose the appropriate astronauts to perform the right mission.
20 minutes to go now till the scheduled launch. But the astronauts up there at the moment with the Shenzhou 14 crew, I mean, they will be doing some of these experiments in the Mengtian, so I mean, they're obviously being trained in this as well. What do you think are some of the major tasks for them that they'll be doing?
Well, I think the Wentian has already provided them with a number of programs for protein crystallization and space seeding. Space seeding is one of the important things because of the agricultural benefits that you can derive from these programs. You expose the seeds to outer space, for example, with microgravity environment, and also expose them to radiations that is stronger than Earth. So we're cultivating them and choose the right seeds so they can have a more productive cultivation and productive production of the agricultural grains. So these are some of the missions they're doing. So for the Mengtian mission, I think they're more challenging because they're material science and material physics and fluid dynamics are very very scientific oriented. So I think the astronaut has to read the manual very carefully to perform these missions. And also I think there are many ground crews and scientific communities are supporting them on the ground because the communication is very easy. It has been made easy for the astronauts thanks to the telecommunication satellites that is operating on geostationary stations. So we have a non-stop communication with the station 24/7 at this moment. So astronauts' conditions, space station telemetry and parameters can be timely transmitted to the ground control station. As you have just heard, that they're rehearsing a number of times for TT&C missions. So these are very important elements for performing scientific missions and supporting astronauts' life in orbit.
Right, Mr. Xu, you mentioned seeding there earlier. Actually, remember that we watched one of the the science lectures from the space station together. So the last one that was held, actually the astronauts showed us a little sample that they did of seeds, right? And one of the children watching from Earth asked a very good question. How does the seed know which way is up? So I want to test your knowledge here.
I think the seeds doesn't know which way is up because what we call photosynthesis is very important for the plantations and vegetations. I think the seeds search for lights instead of search for directions.
That's right. That was the big reveal that we had. I mean, I was trying to figure it out myself. So.
Well, also they're doing a lot of other things like silkworms and spiders. They put them to space station to let them to form their own webs. And on Earth they know the gravity and they know how to operate, and so they have to perform this same mission, like a spider web on station. So
we didn't get to see that. Hopefully next time they'll do.
Yes, this was done, I think, more or less on the International Space Station already.
Oh, wow. I wonder if they'll be doing something like this in the future on the Mengtian and the Wentian. But the Mengtian, so there's there will be a lot of international cooperation as well on the China space station, right? And I know a lot of some global ideas, experiments have been pitched, and some of them have already been selected. Do you have any? Can you tell us about some of these?
I think there are more than 60 has been proposed to the China Manned Space Office. And also, we're using the United Nations. There's an office for outer space affairs, UNWUSA. They're performing this mission on our behalf to all the countries, in particular developing countries. There are different criteria. Their criteria, I think one of them I remember is that they have not done this experiment on the International Space Station, and they have new novelties, and they need to be timely manufactured. So these are some of the criteria and elements. My knowledge is that the first batch of nine projects has been selected, and I think some of them are being delayed, one or two of them, because of technical reasons. But most of them are preparing for their trip to the Chinese space station, and they're also opening this again for the second batch.
Well, they just announced the 15-minute countdown now until the launch of the Mengtian module.
So different time of countdown reflecting different missions and taskings. For example, the 15-minute countdown would mean that the evacuation has to be performed at the launch pad.
Around the launch.
So the people either has to be 2 kilometers away from the launch pad. So you see one of the umbilical core has been disconnected, and 2 of them has been disconnected. These are providing. So this umbilical core is for providing, as you see, it's connected to the fairing itself, very much on top of the rocket. It is providing the electricity, communications, and battery support to the payload itself. Let's say the Mengtian segment itself. So there are different payloads that needs to be charged and electronically switched on for the whole process, so that you can follow not only the rocket itself but also the Mengtian itself before it performs a number of maneuvers. For example, once it's inserted in orbit, it has to deploy the solar panels. So all of this needs power. So the Mengtian itself is currently what we call switched on already. So it's on power. So the umbilical core provides some of the ground segment power, So once disconnected, the Mengtian itself is on its own battery until the moment it deploys its solar panel to provide more charging. So it's currently
to conserve power.
Yes. So as I said, 15 minutes and less, you have to people have to evacuate the launch pad, and there is also a closed-up people that has some bunkers nearby. So you have to hide yourself in the bunker. So, but these are what we call environmentally friendly rockets. They do not have highly toxic fuels. So that is one thing less to worry about, because if you using conventional fuel, you have to use the mask to avoid any accidents.
But that's people being quite close to the launch pad. If you
exactly, and also the people are also fueling the engine itself. So this is very much what we call it environmentally friendly. You have to just worry about the safety itself. So you have to hide to the bunker, and the disconnection of the umbilical cord means that the launch is imminent. So we will have very soon the people who are gone from the launch pad itself. As we have just seen an hour ago, the journalist who was there reporting.
Right.
I think that was just about
he said
less than a kilometer.
Yeah, he said about 300 kilometers.
300 meters, yes.
300 meters away. Yeah. How far away is the ground control station then?
Oh, well, the ground control station has a whole network of different ground stations. The headquarters in Xi'an, so they're in charge of all the controls, and their ground control station has a TTNC linkage to the satellite, to the rocket, and also the satellite itself. So there are different stations that are reporting to a whole network to control, and
tracking
also
its trajectory.
That's the and also we have infrared tracking and also optical tracking. These stations are located on site, very close to the launch pad. As we have just seen the crowd, and just behind the crowd there's a little hill. That provides the optical observation site. So optical tracking is important for the first 10 minutes. Or first few minutes, I think, before the rocket disappears into outer space. And also the infrared tracking can continue a little bit longer, because that when you launch the rocket, you have a very big infrared footprint that can be tracked. And also we can see from the ground, if you're seeing this on a clear day, you can see the separation of the 4 strap-down boosters. That's a few minutes after the launch, but I doubt it. In such a day, I'm not sure you can see that all the way up to the separation.
I mean, the crowds at the beach that we were seeing just now, I mean, they're a few kilometers away from this.
They are about 8 kilometers away. And you from the beach, you can see there are 2 structures. This structure is for the Long March 5. There's another one for Long March 8. Long March 7. So these are 2 10 minutes launch pads.
And how much would they be able to see from where they are? I mean, 8 kilometers away. That seems like a long distance. But then I guess with the visibility being a bit low, but would they be able to feel much from the launch itself? I mean, I know if you're 2 or 3 kilometers away, you can feel the vibrations, right?
They can see the lights. I mean, there's a firing from the rockets, so they can see all the way, I think, to the cloud, and also they can hear the acoustic sound of the rocket itself. 2 or 3 kilometers may be very strong, can be shaking. But this distance, you can still hear it very clearly.
All right, well, I think we are now just 10 minutes away from launch. So it's a pretty exciting moment. And the astronauts up on the space station, what do you reckon they're doing right now? I mean, the docking is going to be completely automatic. So are they just sort of just kicking back, relaxing, waiting, or is there a lot of important stuff for them to do as well?
I think there's tuned in to CCTV to watch the launch. I mean, I think they're listening to the ground control and command communications. Particularly, they have to be very careful in preparation of the rendezvous docking. So as we have seen this launching, the the astronauts probably have already performed a very dramatic maneuver of the station. So the station has to be turned around.
Oh, right.
The rendezvous and docking port has to be prepared, and airlock has to be prepared, and also there's also a detection of the Mengtian capsule once it's in orbit, either by radio communications, and then by laser, and then also by optical. So there are different aimings for the rendezvous and docking. So rendezvous docking is very important and very precise, because if you have a collision, that means a catastrophe, because there will be an air leak and many other things. This happened in the Russian station, called Mir station. They had this accident before, so it has to be very careful in rendezvous and docking, and very precise. You have to use laser beams and optical alignment and also control of the speed.
And they would have prepared for this.
This was prepared as this was mentioned, that this segment is prepared in Shanghai. I visited that academy, Shanghai Academy of Spacecraft Technology, Spaceflight Technology. Though they have a floating table, so they use the air to float the payloads, and then they move the payloads around by themselves to perform the rendezvous and docking testing on the table to simulate the microgravity environment. So the air floated payload has been prepared and has been
at the full size.
At the full size, right. Yeah. So it's very so the table is very big, and also they perform this testing many times to avoid any unforeseeable issues.
Would the astronauts also have to train for manual docking as a backup?
Exactly. The astronaut has been trained very well for manual dockings and manual disconnections, and emergency escape plans, and there are many things that the astronaut has to be trained. So I think the astronauts currently is very knowledgeable in the station, and also we have seen that these astronaut has been staying there for a sustained period of time, and these crew has welcomed 2 segments. So they have the previous one experience.
Right.
So they have something in their mind that they know what they're doing, and also once this is done, they're expecting another crew to come by the end of this year.
6-minute countdown now. If things were to turn into a manual docking, so would it be the space station, would the astronauts be moving the space station towards the lab module itself?
Well, I think once it's turned into a manual docking, also you have to have a control on the segment that you're going to be docked. Yeah. If you're docking with an uncontrolled, uncooperative object, then you have to maneuver the station itself. But the station is much bigger than the Mengtian segment, so the segment has to be controlled. So manual docking, that means teledocking by controlling the Mengtian segment to dock with the station.
And they would have control of the Mengtian segment from the space station as well, or would the control purely be with the ground staff?
The ground staff has to pre-program the whole rendezvous and docking programs,
right.
and what we call insert it into the testing of the satellite itself. And then the ground control is responsible for the rendezvous and docking at this moment. So if you switch to manual, that means the ground give all the authority to the astronauts. Yes. Okay. So the astronaut will have control of this spacecraft as well as the segment.
I mean, how difficult is this? I mean, I guess it's hard to sort of compare, isn't it? But we're talking. I mean, 2 fairly huge objects in space finding each other, but in reality, in practice, this is how challenging. What kind of difficulty level?
Well, there are 2 different categories. I think one is that you are working and orienting an uncooperative object. That is more challenging. For example, if you are catching an asteroid with a spacecraft, that you have to maneuver yourself around the asteroid. So this was part of the plan in the exploration programs in NASA. Another one is both objects are controlled, and you know the parameters, you know the orbit, you know the height, you know the speed. So that is relatively easy. And in particular, this one, you have the focus of the astronauts and the ground crews and the stations, and you can carefully calculate, even starting from this moment, that's happening in 5 minutes. The launching time of the segment can be controlled in such a way that once you're in orbit, you're in alignment with the spacecraft, with this station. So that is more or less, if you control the Mengtian precisely, that can have very easy rendezvous and docking. But as I mentioned in the beginning of the program, that the Mengtian is massive and one of the largest payloads we have done so far. So maneuverability is very important, in particular once it's in orbit. The 23 metric ton needs to be maneuvered very carefully.
3-minute countdown now. But in the 3 minutes that we have, Mr. Xu, so I just want to wrap my head around something, if you're going to just explain to me. So, I mean, these objects, so the space station is, if left to its own devices, it drifts, right, in space. So then
it turns, tumbles, drifts, and comes down. I mean, we had experienced this before at the previous mission of the testing mission. That was uncontrolled somehow. So once you're not controlling this, it will come down gradually, and after 250 kilometers altitude, it comes down very quickly within weeks. So now we're talking about, for example, the International Space Station. It is fueled by the Russian. So the Russian is responsible for maintaining the altitude of the station. So you have to constantly fuel them, to propel them, to push them to an altitude, and then control them into a manner that can be flying, not tumbling, not turning. If it's uncontrolled, anything can go.
So right now, to prepare for this docking, the astronauts will have to essentially adjust the space station to the right altitude, but also attitude, right? Is this the right word for this? The attitude, kind of its relation to something else, and keep it at that precise, I suppose, angle or whatever it is that's needed. Do they have to constantly sort of keep on the controls, or can they leave the space station to sort of do its own adjustments?
But I think starting from the very first satellites, the altitude control has been automatically controlled already.
Okay.
So more or less, let's say, the whole process is controlled by computer. So the position.
1 minute to go now.
So the position is is automatically controlled, and also the attitude.
So 1 minute to go, and they were preparing for ignition very soon. And how long is the journey going to take for?
Roughly 10 minutes, because it's a very powerful engine, so it can go directly to the 400 kilometers altitude with 37 degree inclinations.
30 seconds to go to launch. There's a 20-second countdown to the ignition.
Ten
10 seconds to go.
8、7、6、5、4、3、2、1，点火！点火！
There it is. It's been ignited.
起飞，T 0 150单拐分2.3秒，191毫秒，150单拐分2.3秒，191毫秒。
Has lifted off with the medium nav module. It's cleared the launch pad. They've got a pretty good view from where they are.
Exactly. And also you have heard that the technicians have reported the timing. That is the route time for calculating the orbit. So that timing is very important for calculating when it is to be separated to orbit, and then this is very important for the preparation of rendezvous and docking. So you see, this is the optical track. So this can be only seen by an optical telescope.
文昌光学雷达更正常，遥测向正常，文昌飞行正常。
We're hearing a series of reports.
It's already in the cloud, I think. So you cannot see very
You can
clearly.
just see the flames there.
阵地112更正常。
But despite the cloudy conditions, I think they're managing to get a pretty good view.
But the cloud was there for 3 days and 4 days. They have just seen about 30 seconds. So this is the camera on board the main booster. So you're seeing two of the strap-on boosters, left and right. So this is on the core segment. You'll see very soon that this strap-on booster will be separated from the main engine, from the main body of the rocket.
And we can expect that in just a few minutes, perhaps?
Yes, I think it's happening any minute now. So we're seeing that. So you can see there are 5 flames. One is the core flame, that is hydrogen and oxygen. So this engine has very...
It's burning out a little bit, isn't it?
Yeah. But you know, this engine is very particular because the higher it flies, the more powerful it is. I mean, what we call it the ratio, propulsion ratio. It's more efficient once in outer space, but the kerosene is more efficient on the ground. So we're using the kerosene as a booster, and then the hydrogen and oxygen will be used for outer space flight. So you're seeing these strap-on boosters will be separate very soon once the fuel is burned out.
And then they will just fall into the sea?
They will be falling into the Pacific, yes. Well, that's the whole trajectory. They designed this launch site in Hainan so that it does not fall on the ground and a habited area.
And then we're seeing that little, that's a simulation.
So that's the simulation. This, you see this is burning out, so the flame is not as powerful, so it will have a separation very soon.
And then will they be retrieved at all, or will it just be sort of left?
Current plan is drop into the ocean and give it to the fish. But we do have, you see there's a separation. So that will be dropped already. So now the core engine is the only engine that works. We call it YF77. This is the new generation liquid carrier hydrogen and oxygen engine. So this, I think, is inside the fairing. So the next maneuver is the separation of the fairing. Once in outer space, we call it 110 kilometers altitude, the fairing will be separate. You can see the middle is the seam of the fairing. We're using some pyrotechnics to separate the fairing once it's in altitude, because there's no atmosphere to drag the rocket. So you see the separation of the fairing. Right. So the fairing has been dropped. So
this is all very quick, isn't it?
So yes. So now that means that the rocket is in outer space. There's no atmosphere at this moment. So you're seeing the images now is the Mengtian itself, the segment itself. So the next move would be the separation between the Mengtian and the rocket itself.
Right.
And the finale would be the deployment of the solar panel. So that's what would be considered as a success of the mission. That once you deploy the solar panel, that means that you have a right altitude and a right orbit, and you are ready to perform the rendezvous and docking.
So that's the main booster that's still going there, right? That we can see the simulation.
Yes, that's the what we call it the single stage rocket, because the strapped-on booster with the one engine can kick the whole payload into orbit.
Obviously, the boosters carry the propellant, but once it's all used up and it's unwanted weight, it needs to be shed. But how much weight are these boosters?
Well, the boosters, this segment is about 20 metric tons, but once fully fueled, it has the rocket itself, along with the fuels, has more than 800 metric tons.
Oh, wow.
So, but once it's in orbit, the fuels are all burned out, and what you have left is the fuel container along with the engine itself. So that has, once it's in orbit, after the separation, it will slowly come down to Earth, and it will be disintegrated by burning in the atmosphere. So nothing will be left, and there's no danger posed to the humankind.
It's very environmentally friendly. Nothing left.
Yes, but the separation is happening at the very high orbit, about 400 kilometers above the Earth. So the coming down of the final segment, we call it final segment, even this single segment, the final segment has to take some time. So there's a what we call it international norm or practice to what we call it passivate the final segment. Passivate by passivation we means that we discharge the batteries, we vent the containers so it does not pose explosion danger in orbit. Because with the solar radiation sometimes increase the temperature and some of the containers can fragment in space. So we use a passivation technology to make it into a dummy, so it can slowly come down to Earth and disintegrate it in atmosphere.
How long would that take?
And that can take differently. I mean, it can be years.
Wow.
Yeah.
And is this something that, would this be considered something fairly new, or is this something that's always been the norm?
This is norm. The passivation is relatively new. Before that, we don't consider passivation as very important. Now we consider the Earth environment. You have to minimize the space debris. So passivation as well as the what we call end-of-life propulsion of the satellite is also very important. Either you push it back to atmosphere or you push to the what we call a graveyard orbit, so that you can move away, make ways for new developments.
So how long do you think we have to wait until we see the Mengtian?
The launching is roughly 10 minutes, more or less.
Okay.
So I think in 2 or 3 minutes, maybe 4 or 5. We're seeing the end of the propulsion of the engine, because the engine has its own capacity of fuel, and fuel has to burn out, and it does not have a second kickoff. So it's a single burn. So once you see the engine cease to burn, that means that we'll have separation. But before this, the engine cease to burn, there has to be a control of the rocket to insert the. So you see they shut off the engine. So that means the separation is happening.
It's happening right now. There it is, the Mengtian lab module separating from the Long March rocket.
What you see is that's
the
rocket itself. Yeah.
So the camera is on the rocket, but we're seeing the Mengtian separating from it. So it's on its way, and how long do you think before it docks?
In seconds, we'll start the deployment of the solar panels, and I think the astronauts are able to communicate now already with Mengtian, and the ground crew is to control the deployment of the solar panel before they make any movement, because the batteries are limited on board, so they have to be very careful on the next procedure. So every procedure is very carefully designed. So you see the separation.
Energy.
Exactly. You see the separation of the segment that does not have any major tumbles and turnings. So that means the altitude control can be easily done. So that is very important for the preparation of the docking.
So once the solar panels are deployed.
Jinshan, 我是文昌。华山，我是文昌。文昌参见分离点参数，出轨根数已发出。井上。华山。我是文昌，华山，请讲。 文昌收到。
文昌明白。北京，文昌报告。下面请文昌发射场区指挥部邓红琴指挥长宣布发射任务结果。
Yes, there's what we call alignment in 150 kilometers, 30 kilometers, and then 10 kilometers, 5, and then up to the meters. So for alignment, there are many maneuvers that you have to perform before you go ahead for the final docking.
各位领导、专家、同志们。
Distinguished guests, their leaders, according to the flight data of Long March 5B Y4 and according to the calculation of Beijing Space Control Center, our Mengtian lab module has entered in the orbit successfully. Now I would like to announce a successful mission has been accomplished. Here, on behalf of the Launch Site Command Center, I would like to extend a sincere gratitude to all the distinguished colleagues and dear experts and distinguished officials for your kind support. This is the end of today's mission. Thank you very much.
That's it. That's the last of the hardware, isn't it, for the space station?
Every time they have a launch, the screen turns red. I mean, we're still used to that reddish thing.
It's our auspicious color. So then the next stage, once this docks, the space station is complete, essentially. Right?
What we call it, the completion of the structure, the T-shape.